Okay, now we are starting for question number 7. Let two charges which has the value plus q and minus 2q. These have been placed at A. Okay, now these charges are along this line. So now we'll have to find the condition, the location where the net electric field due to these charges will be 0. Okay, the question is, so for the solution, let first of all we are using vector summation of these vector notations, or we will use the direction of electric field. Due to this plus q charge, the electric field will be like this, along this line. This is, and this is the direction. Due to this minus q, the direction of field will be like this. So now we will find 2 points where the charges will have. Now we will have the points where the electric field will be 0. Okay, let at this direction, due to plus q charges, the field will be here, and minus 2q charges, the field direction, let it, this is the point. Then the direction of field due to plus q or due to ea, this is due to eb, and this is the direction, this is due to ea. So let the distance of this point is x from a, and the distance between these 2 points is d. So now at this condition, ea should be equal to eb. So net e at that point is 0. So ea k q upon x square, this should be equal to k minus 2q upon d plus x square. Okay, so now by solving this we can find this. Now we are not supposed to use minus 2 sign because we have taken it in consideration. So d plus x square equal to 2x square. By solving this, d square plus x square plus 2dx to 2x square. So finally d square x square minus 2dx minus d square, this should be equal to 0. And by solving this quadratic, we will find 2 points where this field will be 0. Okay, but we know that two values will not be true for this condition, because when the field will be considered due to this right side of this charge b, which is at b, the field due to minus 2q is very strong, and the field due to plus q will be very less strong in comparison to b. So at this point eb is always greater than ea. Okay, at this point both are in same direction, ea and eb are in same. This is true only for up to this region. So this is the thing. By solving this quadratic, we will find two location of x, and in this location only one point is correct. This will be this. Okay, now add question of this. Now we will have to find the net resistance between a and b. To find this resistance, we will use Wheatstone concept. We can see this is R1, this is R2, this is R3, and this is R4. So this, let this is R5. Okay, now we know that by the Wheatstone concept, here R1 by R2 is equal to R3 by R4. So due to this resistance R5, so we let this point is 1 and this point is 2. So V1 will be equal to V2, means the potential drop between 1 and 2 is 0, means potential of point 1 is same as potential of point 2. So current through R5 is 0 and the resistance, there is no current, means it can be removed from circuit. So we can draw this circuit again like this. So RAB will be simply, this net resistance is 10, simply the net resistance is 10 and the net resistance this is 10. So this again can be written like this, uh, sorry 20, and this is also 20. So this circuit can be written like this as 20 and 20. So this is again by the parallel combination, this is equal to 20 by 2, it means 10 ohm. So this is the simple value. Okay, let a circuit is given. In this circuit, a bulb, three bulbs are connected in a parallel. Okay, now 6 ampere current enters in this circuit. Okay, both, all the bulbs have same rating. Okay, means the power and voltage are same for these three bulbs. Now since power and voltage is same for these three bulbs, it means the resistance of bulb, let it R1, this is R1, R2 and R3, this will be same. So R1, R2 and R3 will be equal to V square upon P, let it R. Okay, so now when all three bulbs are connected, these are in parallel, so voltage drop across this combination will be equal. So V will be equal to all three bulbs. So V1 equal to V2 equal to V3 and that is equal to V. So the current will be equally divided. Okay, so I1 equal to I2 equal to I3 will be equal I dash, and let this 3 I dash, this should be equal to 6 ampere. So I1, so 3 I dash is equal to 6 ampere. So I dash will be 2 ampere. So by using this, when one bulb is fused, now if one bulb gets fused, then then what will happen if this is fused? So R1 will be 0, means let R1 is fused, so R1 is infinity. Okay, now no current will pass through R1, so in that case all 6 ampere current will be through R1, R2 and R3, but the potential drop cannot be increased. So the voltage is same at this point, still is V. So the current drawn from the battery will be by I2 will be V upon R and I3 will be P upon R. This is equal, so I2 equals to I3. So I battery, the current which is drawn from the battery will be equal to I2 plus I3. So in this case, I drawn from battery, this will be equal to I2 plus I3, and this is same as V upon R plus V upon R. We know that one bulb draws 2 ampere. Okay, so this will be 2 plus 2, it means 4 ampere. So the current drawn from the battery in that case will be 4 ampere. In the next question 10, wire A and wire B, this is uniform wire. Let two wires have been given to you. These are uniform wires, wire A and wire B. This has length 12 meter and this is length 18 meter. The mass of the first wire is 50 gram, while the 50 gram this is of MA and MB is given to you. This is 40 gram. Okay. Now you will have to find the ratio of resistance of these wires RA and RB. Let the resistance of this wire is RA and the resistance of this wire is RB. So now to find the resistance, we know that we are given M1 and M2. So MA and MB, it is given us to 50 gram and 40 gram. Now ma is what? Simply density into volume Va. Now rho to Vb, this is equal to 50 by 40. Now rho to rho cancel out because the material is same, means density is same. Now Va is what? Simply volume, and volume is equal to length into area, so La into Aa upon Lb into Ab. This is 5 by 4. La is given to you 12. Area simply pi Ra square, or simply let it be area Aa, and 18, let this be AB, 5 by 4. So by this we will find AA and AB. This is 5 by 4 into 18 by 12, so it's simply 15 upon 8. Now this is the value of ratio of area. Now to find the resistance RA and RB, we will simply write it down as LA upon AA upon rho LB upon AB. By this is LA is what? LA, the length is given to you 12 upon 18, and we can write it as AB upon AA. Now this is 2 times and this is 3 times, so 2 upon 3, and again AB by AA, this is simply add by 15, it means 16 by 45. This is the ratio of resistance of these two wires. Okay, so these are simple questions based on the electrostatics general principle and based on electricity. In next chapter we'll see the different questions. Okay, thank you.